And we're into our last chapter of the first semester, chapter 7. As we skipped 7.1, that's just an introduction. So this is around December 1st. And we have our warm-up question. We've had questions like this quite a few times, so hopefully you've already done it. Pause it, do it now. So that's point-slope form again. Opposite of x, opposite of y, slope. So 3, -5 is down here. Slope is down 3 to the right 2, or up 3 to the left 2. Okay, we can continue that across there. And always go to the end, one end, and then line it up on the other end as far as possible across there. Okay. So there's our first line. Now we move over to the next one. This is in slope-intercept form. There's the slope. Here's the y-intercept. If we let x equal 0, then y would equal 6. So 0, 6 is up here. And the slope is 2/3, positive 2/3, up 2 to the right 3. And that intersects perfectly right here, which is what we would have expected. And going across there. So again, I'm going to use this point over here, and I'm going to use this point over here, opposite ends, to try to get this in the right place. And we graph these lines. For our purposes, they should cross perfectly. That's off a little bit, but it should be close enough for me to figure it out there. All right, this next one is in standard form. And standard form is when we let x equal 0. And if we let x equal 0, then we divide by 4 and y equals 6. Or we let y equal 0 and divide and x equals 4. So 0, 6 is right there, and 4, 0 is right here. So if we look at that, that's going down 6 over 4. So that's -3/2. So -3/2 is right there. And I'm not sure how far that's going. We can do something like that. And we have another standard form here. So as we start to do this, and we let y equal 0, if we let y equal 0 and we divide both sides by 2, we get 4, so we get 4, 0. Now if we try to do that with y, it doesn't turn out very nice. If x equals 0, we get -8/3. And we don't want to approximate that. That's not very good. So what we can do instead is we can subtract 8 from both sides and add 3y to both sides, and then we can divide by 3. And what we do is we see the slope. The slope is 2/3. So now we can use this point in this slope. Now we could look at y equals mx plus b, but again, that's not very nice. -8/3. We don't want to approximate that. So we would rather not approximate that y-intercept. But we can use this point, and we can use the slope here. We have the 2 points right there. We're basically done there. All right. So classify the quadrilateral formed. So we want to look at that, and we can see maybe that we have, this was -3/2, so those are parallel. We can see these are both 2/3, those are parallel. So it's at least a parallelogram. But now, if you look at that, -3/2 and +2/3, those are opposite reciprocals. And that means that those are perpendicular, and that means those are right angles. So that means that actually that's a rectangle. Okay, so if you put parallelogram, that would not be specific enough, and we would not get that point. Now, we're also asked to find the perimeter in the area, as usual, and so here the perimeter, we want to focus on those units. That's why I have this highlighted to make sure that we get our units on there. Okay, so the perimeter, if we look at this, let's get the short side first here. So that makes a right triangle, and that's 2 by 3, so that's going to be 2 squared plus 3 squared equals c squared. So that's going to be root 13. And that means this side down here is also going to be root 13 because opposite sides of parallelogram are congruent. So we have root 13 so far. Now let's find that red side. Now if you look at that, that's 6 and 4. But if you think about it, maybe you could find it faster. A squared plus b squared equals, so that's 36 and 16, that's 52. That is 4 root 13, that's 2 root 13. Now maybe you saw that because there's kind of two of those triangles. So that's going to be equal to that, and there's 2 of them. So if we add those all up, if we add these 2 up, that's going to be 3 root 13, and then we can double that, so that's going to be 6 root 13. And since they're all root 13s, we can add them together that way and get 6 of them. Okay, now sometimes we try to chop this stuff up and cut it into triangles or rectangles, different shapes. That's not going to work very easily here, but it's a rectangle. And the area of a rectangle is the base times the height. So what we could do here is just take the base times the height. And when we multiply a radical times a radical, we just get that number, and so the area is going to be 26 units squared. All right. So let's move on to today's lesson, which is reflections. The slang term for reflection is a flip. Just flip something over. So reflection in a line M is a transformation that maps every point P in the plane to a point P prime, so that the following properties are true. So the original point is called the pre-image. Pre means before. Prehistoric means before. Before history. Pre-image means what came before the image, and then the prime, that's the image. So you can think about that like your face. Your face is the pre-image. What you see in the video there is the image. If you look at a mirror, your face is the pre-image. What you see in the mirror is the image. So the pre-image comes before, the image comes after. So if P is not on the line that you're reflecting over, then the line is the perpendicular bisector of the segment that connects the before to the after. If the point is on the line, it stays there because you're flipping it over. There's nowhere. If it's on the line that you're flipping on, then it's not going anywhere. Okay, so let's see how this goes. So the first thing we should do is probably to plot the original triangle. So -9, 2 is right there for you, and -3, 2 is right there, and -6, -1 is right here. So that is our pre-image. That's what we're starting with. Sometimes I'm a little hesitant to label things because I'm not sure where everything else is going to be. So let's try that. Okay. So reflect that blue triangle over the x-axis. So the x-axis is right here. So the points are going to be the same distance away from the line you're reflecting over. So that's going to be u prime. That's 2 above, so it's going to come 2 below. So that's v prime. And this was 1 below, so that's going to be a 1. So that's going to be w prime. So these two triangles overlap a little bit. Alright. Okay, so the coordinates, this is -9, -2, and this is -3, -2, and this is -6, +1. Okay, so now it says reflect it over the line y equals x. So this is probably the most complicated one. So I'm going to put a dotted line in here for y over x. Alright, so I'm going to reflect the blue triangle over the purple line, y equals x. Okay. So, I'm going to start with v, I guess. So diagonally, that's 1, 2.5. So that is going to be over here. So that's going to be v double prime. Now, there's a couple different ways you could look at this. You could realize that that triangle is being flipped over here, so this is going to be in the same place. So that's going to be u double prime. And then if you think about where this was, that was 1, 2, 3, 1, 2, 3. So I go 1, 2, 3, 1, 2, 3. So I could do that. That's going to be w double prime. Now, you also could have just counted diagonally across like we did with v double prime. So you could go here to w, and you could say to flip w over this line, to reflect it over this line, it's diagonally 1, 2.5. So 1/2, 1, 2 would put it here. And you could do the same thing with u and count that all the way over there. That's kind of far, but you still could. So that's 2, -9. And this is 2, -3. And this is -1, -6. Alright. And our last one here is over the line y equals 4, which would be right here. So this is going to go up here. It's going to be u triple prime. This v is 2 below y equals 4, so it's going to go 2 above. Okay, v triple prime. This line right here. And then this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is going to be w triple prime. So that is -9, 6. This is -3, 6. And this is -6, 9. Okay. Now, what orientation does each figure have? Alright, so orientation is Counterclockwise is positive. So if we're going from the positive x-axis, we're going this way. Positive orientation is counterclockwise. All right, so if we look at U, VW, so that was U, VW. Going from U to V to W like that, that's clockwise. Okay, and so if something's going clockwise, that has a negative orientation. All right. So if we look at, I should have done that in blue. Let's see. So this one's this one's red. Darn it. Okay, so U, this one's like this. U prime, V prime, W prime. So if we connect those, that's going like this. So that's counterclockwise. So that has a positive orientation. When you go, you can sketch a little picture real fast and then draw an arrow between the letters and see which way it's going. So counterclockwise means the opposite of a clock. Okay, this is going the same way a clock goes. If you look at the hands of a clock, it goes this way, that's clockwise. Counterclockwise. Okay. So, let's see here. If you think about it, so what are the coordinates if you go over the x-axis? So a lot of times if we sketch something, that helps us. And the y-axis would be right here. And so, all right. So if we think about it, we have this point right here and we reflect it down here. What happens to the point over the x-axis? Well, the x-coordinate stays the same and the y-coordinate becomes the opposite. And that would be either way. So if we were down here and we went up there, it would be negative down here. So if we did the opposite of negative, would be positive. And so here, the x-coordinate is going to become the opposite and the y-coordinate would stay the same. I probably should have paused and let you think about that, but so that's A and that's A prime. All right. Reflection. A reflection is an isometry. Iso means same, and metry means measure, same measure. So when we take something and flip it over, it's an isometry. It stays the same shape, it stays the same size. It doesn't change any of that. Okay. Now, I think you have a question like this on your assignment, the book. What we want to do here is we want to make this, if we're going to put a cable, now we don't, this would be for a landline. Most probably don't have landlines much anymore, but if you're running a cable along there, or a fiber optic cable for the internet or something like that, you want to use as little cable as possible. It's going to save you money. If you're laying millions of miles of cable across the country to people's houses, you want to try to cut down on the amount that you have to use. So if you have the main line up here and you're going to run it to both of their houses, well, this would be on telephone pole. Optic is probably underground, but anyway, what we can do is we can do a reflection. The shortest distance between 2 points is a straight line. However, a straight line would just connect those two houses, and that wouldn't be very helpful. We're trying to connect them over here. So the idea is that we still want a straight line. So if we reflect this point over, that'll give us where the straight line would be, and that's where we want to go here. So it's not that big of a deal if you don't have a compass, but all right. So I'm creating an arc across there. What that did is it gave me 2 points that are the same distance away from here. Now I can go to the other side over here And I can do this. And what that's done is it's given me the point on the other side over there that is equidistant from there. So now that's A prime. Now if I line that up with B, what that does is it gives me the point here. That's where I want to put it. Because now I can connect this to there, and that's going to be the best place to put that. That's not a big deal if you're like, what? If you don't get anything that just happened there. There's an example in the book, and they might explain it maybe nicely. Okay, a line of symmetry is a line that a figure can be reflected in and mapped onto itself. Basically, it's a line that we can draw and fold it in half, and it lands exactly on itself. So if we take my hands here, hopefully, we fold them in half, it pretty much lands on itself. Okay? So determine the lines of symmetry and draw them. So I'm going to go kind of quick here because my next class starts pretty soon. So hopefully you see this. We can cut this kite down the middle, and if we fold it over, it lands perfectly on itself. So there's one line of symmetry there. Okay? Pause the video and see if you can do the rest of these, or pause and check one at a time. Don't just sit there and copy. So I'm not actually measuring that out. That's pretty close, but so this one has 2. Okay, so 1, 2. Now, some students want to try to cut it across diagonally here. Say, I can cut it in half. That does cut the area in half, but if you fold it, this point goes over here, and this point goes over here, and it doesn't fold on itself perfectly. So that's not going to work. Now, with a square, I hope you paused and tried some of these. Or pause now and try the last 2. This is usually something we put on a test a couple times. So for a square, this does work. Now you want to be careful here that you kind of keep track. 1, 2, 3, 4. Do not keep going because that's the line that we already have there. So we have 4 of those. Okay. Now here, hopefully everybody kind of sees that one. And maybe you want to cut it this way, but let's kind of stick with the same thing here. So we just cut the sides in half directly across from each other. So if we move around here and stick with the sides, that'll happen 3 times. Okay, so we have 3 so far. But if you think about it, especially the kind of cutting in half this way, we can also do it through the vertices since there are an even number of vertices. Okay, so we can go through there like that. And that's going to be 1, 2, 3, 4, 5, 6, and we get back to here, that's the original. So this one has 6 lines of symmetry that cut it in half perfectly. Alright, and then we have a little review question here. Which one would be a parallelogram? So in a multiple choice, you could just check. So we're trying to match the slope here. So 2, 5 would be right here. Okay. So if you check the slope here, that's 3, 1, 2, 3, 4, 5, 3/5. If you check the slope here, 1, 2, 3, 4, that's 4/5. So these 2 sides would not be parallel, so that's not going to work. Okay, so that's not going to work. So let's try 212. 212 is up here. Okay, now I can see the left and the right side are parallel because they're both vertical. So that's fine. So now if we check this out, that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that has a slope of -1. And this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is also a slope of -1. And we have the 2 vertical sides, so that's going to work. Now normally, I would check these other 2 if I had time and see if they're going to work or not, but I got a class to go to right now, so it's about that time. Have a good day.